Welcome to Air and Space Forces Magazine. I'm Tobias Naegele, Editor-in-Chief, and I'm joined today by John Shade, Executive Vice President of Business Development and Future Programs at Rolls-Royce North America. John, welcome.
Thank you.
So Rolls-Royce, old name in defense, Merlin engines from World War II, but you're not exactly a legacy company anymore. You're a company on the move. Tell us about how Rolls-Royce North America is evolving.
Yeah, and so thanks for having me. Really excited to have this discussion. So you're right. We have a long and storied history and legacy in the United States. Spans back over 100 years, as you reference, and it's just been an exciting journey. And as of late, you probably have seen the company has been through a lot of change the last few years, and really find ourselves in a really good position right now. Again, looking back over that past 100 years, we're incredibly proud and humbled to be part of so many important programs and platforms for the U.S. Department of Defense, and supporting the warfighter on platforms like the C-130J and the V-22, of course the Global Hawk, and some of the recent wins like the Army Future Long Range Assault Aircraft, the MV-75, and then certainly supporting the U.S. Air Force on critical nuclear deterrence capabilities, including the re-engineering of the B-52 platform, which we're going really well, and I'm sure we'll talk about a little bit more later. But as we look forward, I think we find ourselves that the conditions today are really ripe for a global company like Rolls-Royce to really excel and increase kind of our presence and our investment and our partnership in the United States, and specifically to support the warfighter. If I look around the globe, we actually have a bit of a unique position where we have full capabilities. I'm talking like engineering, development, manufacturing, assembly, test, the complete suite of capabilities in 3 different continents, 3 different countries. So in Germany, the UK, and the US. And of course in the US, our main facilities in Indianapolis, Indiana. And that's where we do all the design work and the manufacturing and production and development for all those platforms that I mentioned earlier, plus others. And I think the climate right now, as I started to say, the conditions are right for us to really lean into that and partnering and bringing those global capabilities to bear for the U.S. Department of Defense in some really exciting new areas like autonomous collaborative platforms, and even in secure and resilient energy through the use of nuclear solutions. And happy to talk about those more.
Okay, so let's get back to nuclear in a little bit. I want to first go to the B-52, which is really a monumental program for the Air Force, extending the life of airplanes that are 60 plus years old and keeping them flying potentially for a full century. You're doing the engines.
Yes.
So those would be 8 new engines on 76 B-52s. What's the status of that program, and where are we, and when will we start seeing flight and that sort of thing?
Yeah, so I mean, really exciting times. The program, first of all, the program's going exceptionally well. We continue on cost, on schedule, and have really achieved some significant milestones as of late. We've been doing a lot of twin pod testing. And as a matter of fact, we've wrapped up that twin pod testing, and it's gone exceedingly well. We've been able to validate all our models and validate our assumptions and our requirements that we're hitting the mark.
This is a single pod that is holding 2 of the F-130 engines side by side. Never been done before.
Yeah, absolutely. And so one of the keys of this it's the B-52 commercial engine replacement program. We actually, if I'm honest, it really was, we had an off-the-shelf commercial engine that's used in business aviation, on business jets, from our BR family of engines, that was absolutely a perfect fit for installation into the B-52. And so we took 2 of those commercial engines, go into each of these twin pods, and to your point, that's a bit unnatural, especially for a commercial engine, but really leading up to the award of the contract, I think besides being an exceptionally good fit for the platform, a lot of work we did was really to burn down risk around putting 2 commercial engines in this twin pod. And so we did a lot of subscale work, a lot of digital modeling work, and kind of went back and forth between physical and digital over and over again until we could convince ourselves and ultimately the Air Force that this was a very achievable endeavor and with low risk. And so now we've been able to actually test the engines in the true twin pod on the ground and validate our models, and it looks really good. So that was a huge milestone to hit that and really build some confidence that the integration is going to work and look good. Some other big milestones, we've successfully completed our critical design review. So that's obviously a really big milestone for the program. And we've already started altitude testing with our first altitude engine. So again, we did a lot of work ahead of the award, kind of leaned into it a little bit. We actually upgraded one of our test cells in Indianapolis to be able to accommodate the F-130 engine, a cell that was more used to down in the AE class. But we upgraded it and actually did quite a bit of testing on the F-130 engine before pre-award. So that helped us make sure we had the infrastructure to support all these tests and milestones. And so now we've been able to get to an altitude test pretty quickly in the program, which is also a big benefit.
Now you mentioned the AE engine series.
Yeah.
And that's kind of that's the
Bread and
bedrock,
butter.
bread
Yeah.
and butter, Allison engines kind of history.
Yeah.
That's on the C-130J.
Yes.
It's also the V-22.
Yes.
So is that a legacy engine that we're kind of going to eventually wave goodbye to, or is that an evolving proposition
Yeah,
also?
so great question. Yeah, the AE is quite a remarkable story. We have turboshaft variants like is on the V-22 Osprey. We have turboprop variants like on the C-130J. And then we have turbofan variants on the Global Hawk and the Triton. Right. And most recently, the Navy's autonomous tanker, the MQ-25.
So is it the MQ-25 is using the same engine
on that? Yeah, which is really great. Really great because it's also bringing us some of that autonomous operation experience. And although we've gotten that previously with Global Hawk and Triton, but MQ-25 is kind of taking it to the next level. And some would call that the Navy's first foray into CCA, if you will. So in fact, we've got a series of commercial applications that's been on commercial turboprops. The engine's still on commercial regional turbojets, or turbofans rather. And as a matter of fact, we've got over 90 million flight hours on that family of engines. I'd say probably 75 to 80% of those hours are actually on commercial applications because they fly so much more. But if you can believe it, the most recent win with that family was the Army's Future Long-Range Assault Aircraft, the MV-75. That is a derivative of the 1107 that's on the V-22. And that is actually the 17th application for the AE product family. So it has been just an incredibly remarkable family of solutions. We're well over 7,000 engines, as I mentioned, over 90 million flight hours, creeping up on 100 million. And the interesting thing I don't think people appreciate is we've never stopped investing and upgrading and improving and adding capability to those platforms, as demonstrated perhaps by being selected for the MQ-25 and most recently the MV-75. In fact, in just the last 10 years alone, we've invested well over $1 billion in technologies and capabilities for the AE family to make it more reliable, to make it lighter, to make it cheaper, to make it more survivable, to make it more cyber secure, and a variety of other features, increased range and performance and loiter time. And then we've invested significant money to completely overhaul the factories, the manufacturing, assembly, and test for both development and production in Indianapolis. So those facilities, as you alluded to earlier, going back to the World War II days, those facilities in Indianapolis were originally constructed during that time, and literally wooden buildings, and they had seen it all, but it was time for a massive overhaul. And so we literally, in the last 10 years, essentially tore that all down, gutted all the factories, and refit them with the latest, greatest digital tools, artificial intelligence, manufacturing techniques and processes. Again, test cells. We've just kind of redone the entire campus, and it's truly state of the art now. So when you look at the AE from every facet, whether it's technology and upgrades in the engine, to development and testing and manufacture and production, assembly and test, every aspect of that now has been completely refreshed and modernized and has the latest, greatest. On the technology side, just one or two specific areas, we've introduced a completely new modern FADEC, electronic control system. Mm-hmm. So this is state-of-the-art, best-in-class, modular design so that design changes and obsolescence issues are much easier to deal with down the road. You can make changes much quicker and much less expensively, as well as a full suite of capabilities for cyber, not just for today, but as we see it continue to get more and more demanding, we've built that all in there to be able to really keep pushing the cybersecurity aspects, the modularity, the MOSA requirements, so that we're ready for the next 10, 20, 30 years with these capabilities. Another good area is around survivability. We've got great IR suppressor capabilities and technologies. Our latest products now have the next generation of that design and that technology. And what's
so
really
this is actually adding stealth to a legacy product in a sense.
It is.
How do you add stealth to an engine?
Yeah. So again, we have a really slick design approach to infrared suppression. Mm-hmm. We actually have been on the Army's special ops versions of the Chinook aircraft for decades, with the kind of the first generation of this technology. And now on programs like the MV-75 Flora aircraft for the Army, we're introducing the next generation of that on that platform. And we actually have designs for things like the C-130 and certainly autonomous or CCA applications. The cool thing about our design, in my opinion, a lot of capable companies out there, but our infrared suppressor has no moving parts. It is all done with aerodynamic features and cooling, and that means the product is incredibly durable, reliable, robust. It does an excellent job at survivability, but this thing just does not degrade, if you will. We get back suppressors from the Army with over 3,000 engines, or 3,000 hours. And literally the thing looks, aside from the small arms fire, it looks brand new. Like there's no degradation to the suppressor. And that's a pretty big feat for a suppressor if you think about the environment it sits in and what it's trying to accomplish. So those are just two examples that we continue to feed into the AE family.
Right. So you mentioned CCAs earlier, collaborative combat aircraft. We tend to think of Rolls-Royce as making big engines. So how do you see yourself playing in that emerging market?
Yeah, I think it's a really exciting space around the whole autonomous collaborative platforms arena. And actually, if I put on kind of our global hat, our Liberty Works counterparts in the UK have actually been working for several years on the smaller end of the CCA propulsion system solutions, and have a product they refer to as Orpheus. It will actually be at the show this year at AFA, and so I invite folks to come by and see that. And so where we see ACP and CCA covering kind of a broad spectrum of solutions and power classes, we see our Orpheus product in that small to medium range, and then really kind of pick up the AE family in that medium to upper range, and then for the really large range, even the F-130 style engine up there. And again, it's about adding the additional technology insertion or capability insertion, like survivability features, like longer range, higher speed capabilities, the advanced autonomous features, lower cost for some of the applications, which will be larger in volume, lower in cost. And so we're really excited that it looks like a lot of areas that we believe Rolls-Royce could really add a lot of value to that full autonomous spectrum.
So another sense of innovation at Rolls-Royce.
Absolutely.
So another area of innovation, and I guess this is not a new business for Rolls-Royce, but it's probably a new business certainly for Air Force people familiar with Rolls-Royce, is that you're in the nuclear power business and in the microreactor business. Tell us what you're doing there and where you see that evolving. There's obviously for power resilience for bases, remote locations, for agile combat employment, interest in rapid capability to stand up power. What are you doing in that environment?
Yeah, so really exciting. I'll start with a slight detour just for awareness maybe. In the UK, part of our defense business is our submarines business. And so we have actually provided all of the nuclear reactors for the Royal Navy for 7 decades. So Rolls-Royce has a deep history and legacy in the UK with the Royal Navy, which is exceptional. And I only raise that because it does bring a lot of experience with the regulatory aspects, the certification aspects, the development aspects, and how you actually get these things fielded, if you will.
Safety, reliability.
Absolutely. As well as the fuel side of the equation. So if I kind of bring it over to the States, several years ago, the OSD Strategic Capabilities Office launched a project called Project Pele. And there's actually been a really good article just released recently with a little bit more detail than we've been able to talk about. But BWXT, a US-based company in Southern Virginia, they were awarded the contract to go design, build, and essentially field in the U.S. And operate the first of a kind advanced microreactor. The recent article actually pinned down a little bit more detail. This first of a kind will be 1.5 megawatts. BWXT, obviously, they have an equally impressive heritage in the United States for providing nuclear capabilities to the U.S. Navy.
Right.
And in this program, it's kind of leveraging a lot of those capabilities along with their quite unique fuel capabilities to bring this first of a kind advanced microreactor. And what maybe surprised some folks is a significant amount of the project is around the power conversion, kind of thermal management of this system. And Rolls-Royce is providing all of that capability out of our Liberty Works organization in Indianapolis. So if you think about it.
So that's your advanced research laboratory.
It is. Actually, 2025 is now our 30th anniversary for Liberty Works. So we formed it officially in 1995, and it has been it's our technology, our defense technology organization. And it's really all about rapid prototyping, rapid fielding. How do we develop the next capabilities and technologies and get them prototyped and get them fielded? And so for 3 decades, they've been kind of the front end of all these successes, I would argue, that we've experienced over the decades. And so we've developed a lot of really good capabilities for mission critical power, very compact, very efficient, for a variety of applications where you need lots of power, sometimes very demanding duty cycles. And we've built a number of systems for air, for ground, for all sorts of high power demands. And in this case, it was kind of a perfect marriage. And when we kind of got together with BWXT, realized we could really help the program a lot. So BWXT does the reactor, Rolls does all the power conversion and thermal management, and Northrop Grumman's the third team member doing the control system. But super exciting. This, to your point, it brings incredible energy security and energy resilience to places where it's sometimes very challenging. Forward operating bases, as you mentioned, remote operating bases. And one of the points of this one is it had to be transportable. So
what does that mean, transportable? How many C-17s do you break this thing into?
So this entire system, the reactor, the power conversion, thermal management, and the controls fit in four 20-foot container boxes. They can slide into the back of the aircraft. and be flown. And it will actually fly the reactor out to Idaho National Labs in a couple of years now. And it'll be deployed there first and set up. And one of the requirements was to be able to fly it, put it anywhere that you need to, and within just a few days, have the system be up and operational and run for 3 years. That was the requirements for this program. Again, first of a kind, no one's ever achieved this before, and BWXT and Rolls-Royce and Northrop are now well along our way. We're making hardware as we speak, and this thing will be out at Idaho National Labs not too far in the distant future and running.
So that's really a transformational technology, because if you think about dramatic weather events and so on, the potential to have that kind of equipment and then move it into a location and restore power when a reactor has been killed, after a tsunami or after a hurricane or something, and stand power back up, it would be amazing.
Absolutely, absolutely. Yeah, we're really excited about this and see a lot of applications for this, not only on the defense side, certainly commercial side as well. So it's a very exciting space. It'll be great to get that first unit up and running.
Well, John Shade, Rolls-Royce North America, this was really fascinating, and I look forward to hearing more about where each of these programs is going to evolve over the next few years. Thanks for coming.
Thank you. Really, really glad to be here.
Great.